All right. So if I want a polynomial that has negative 3 plus 2i is a 0, what else is going to be a 0?
Negative 3 minus 2i.
Everybody okay with get negative 3 minus 2i? So then we're going to get negative 3 minus 2i. All right. Now, if these are zeros, how do you come up with the factors? Yeah.
So you do x minus both of those?
You do x minus, right? Like so, or like the summary of between the relationship between zeros and factors goes like this. At a really basic level, if I give you x squared minus x minus 6, we get x minus 3, x plus 2, and I get 3 and negative 2 are my zeros. Are we okay? These are your zeros and these are your factors?
Yes.
And so the relationship to get from here to here is you do x minus this.
Yes.
So if I want to create my polynomial, to create my factors, I'm going to do x minus, technically it's negative 3 plus 2i, and then I'm going to do x minus negative 3 minus 2i. Did everybody see how that's going to give us our factors?
Yeah.
And when everything's said and done, you end up with x plus 3, I guess I should be correct, minus 2i, and x plus 3 plus 2i. But to be honest, all you got to do is do x minus, this is x plus 3, and you can say plus 2i and x plus 3 minus 2i, because it doesn't matter what order they're in. All that matters is you get to this stage. Now, what was the trick? How did we multiply these together?
Oh, you put
smiley face.
Yeah, smiley face.
Smiley face. We think of the smiley face thing, and so we remember to put parentheses around the x plus 3's, right? Oh, we put a smiley face there, yes. And now, when we have our x plus 3 there, right, then I end up with x plus 3 squared minus 2i squared. Everybody okay so far?
Yes.
And we end up with x squared plus 6x plus 9. And we get a minus 2i squared, that's 4 times negative 1. So that's minus negative 4.
Okay.
Everybody okay with this?
Yes.
And our final answer is going to be x squared plus 6x plus 13.
Okay.
And I need everybody to have that written down,
Yes, sir.
all right? Because that's actually, I'm going to use that in the last example of the day.
Oh.
All right? So we're going to be using this information later. Right? Did everybody understand what we did?
Yes.
All right? I gave you a 0, right? They come in pairs, so you created the negative version. That's called the conjugate. We created this partner. Then we created the factors, and then we used the little trick to multiply it out. Yes?
Does that say equals 4?
No, minus negative 4.
Minus negative 4. Okay.
Yes.
Is that called the complex conjugate? Like
Yes.
with the 2i?
Because conjugate is anytime you're making the difference of squares, and it's called complex because anytime you're dealing with i's, it's called complex.
Okay, thank you.
Now, all right, so I needed that. So write that down somewhere, and we'll come back to it later. Today, I have to talk about so like Thursday and Friday, I talked about the rational root theorem. And the rational root theorem gave us this idea of guesses. Now, just curious, was the rational root theorem, did it help us that much as far as guessing?
No, not too much.
Not really, right? Because if you do the rational root theorem, you get a list about this long, and you're still going to try plus or minus 1, plus or minus 2, and hope one of those works. So it's part of the curriculum. I teach it because that's what we're supposed to do in Algebra 2. But does it really help you factor something? Not really, right? So today I have to talk about something that's actually worse, right? It helps even less. So if you're wondering how does this help you, I'll go ahead and answer the question. It doesn't, all right? But it's part of the curriculum, and so I have to talk about it, right? So that's the bad news. The good news is it's actually very easy to do, right? It's probably the least computational, the least computational intensive thing we've done this chapter. Right?
Oh.
So what I need everybody to do is write down this function, and we're going to start with x to the fourth minus 3x cubed plus 2x squared plus 3x minus 4. So everybody write that down. All right, so how many zeros does this have?
4.
That's easy, right? So when you find your zeros, some of those zeros could be positive, some of those zeros could be negative. Some of those zeros you'd have to use the quadratic formula for, and you'd get like an I or something with it, right? Does everybody agree that that could happen?
Yes.
Because we've seen some. I've given you problems where you get positive and negative answers. I've given you problems where you get like an imaginary zero, right? So what I'm about to talk about is the title of this is called Descartes' Rule of Signs.
Oh, we talked about this guy. Renee.
Yes. Yeah.
Was he the guy that learned about the
He was the guy that said, I think, therefore I am,
Oh, okay.
right? So, I mean, that's kind of, if you've heard that phrase, he was the guy that came up with it.
Yeah.
All right, so what is Descartes' rule of signs? Well, Descartes' rule of signs gives us an idea of what kind of answers we're going to get. Are we going to get how many positive answers, how many negative answers, how many complex answers that involve an I? And here's how here's how it works. First, you make a chart. You put a plus, a minus, and an I. We're going to have 3 columns, where this column is going to tell me roughly how many positive answers we have. This column is going to roughly tell me how many negative answers we're going to have, and this column is going to tell me how many imaginary answers we're going to have. So and we can find all of that out by looking at sign changes. So as long as you write down the polynomial in order from greatest power to least power, and now we're going to look at sign changes. What's a sign change? Well, this is a positive coefficient, that's a negative coefficient. That is a sign change. This is a negative coefficient, this is a positive coefficient, that's a sign change. Positive to positive is not a sign change, but positive to negative is a sign change.
Yeah. Yes.
Everybody, so we have to be able to identify sign changes. Does everybody see the sign changes? How many sign changes do we have?
3.
We have 3 sign changes, and so that means that we could have 3 positive answers. Okay? Now, how many total zeros do we have?
4.
4. If 3 of them are positive, how many do you think are negative?
1.
1. Perfect. And the first row never has, the first row always has 0 imaginary.
I'm confused. Oh, because we're 4. Yeah.
Okay?
Because we can't have it.
Because we have 4 total,
Yeah,
right?
yeah, sorry. that's
Now,
the question.
here's how complex answers work. Question or stretching? Okay. So here's how complex answers work. Complex answers steal in pairs. Right? They steal in pairs. Meaning, I can steal two answers. So this first time through, my imaginary answers, they're going to steal 2. And they're going to steal 2 from the positive. So if they steal 2 from the positive, how many are left?
1.
1. And we still have 1 on the negative, and so we have that. All right?
Okay. How did they
Okay.
steal it?
Well, just, okay. They put on a black mask and they
Oh,
break into the
okay.
house and steal it. Okay.
Okay.
Okay, now. Okay.
They stole
Now,
Yeah.
so complex answers always come in pairs. Every time you've gotten a complex something with an I, there's always been a plus or minus associated with it. So all of these numbers are always going to be even. But the one thing you have to be careful with is they steal in pairs. They have to steal 2 from positive or 2 from negative. You can't take 1 from positive and 1 from negative. All right? So at this point, we're done. Right? Because I can't steal any more imaginary answers. So if I were to solve this, I'm not going to, all right? That's not the point of this. If I were going to solve this, I would have 2 possible outcomes. One outcome is I would have 3 positive answers, 3 positive zeros, 1 negative zero. right? Or I would have one positive 0, one negative 0, and two imaginary zeros. Yes?
Wait, what happened? Like, what's the next step? Is like you could have stolen another one. Would you add it to like? you
No,
know,
well, I'm going to give another example where we can steal more. Right? Right now, we can't. There's no more ways that imaginaries can steal. Now, just curious. Does knowing that information help us figure out how to factor this?
No.
Not one bit, right? But, so if you're asking how does this help you, it doesn't. But, how much work was it to figure these out?
Nothing.
Not much. Okay, so, that's the good news. All right, so let's try it again. Let's say I have 3x to the 5th plus 4x cubed minus 5x squared
I also don't know.
plus 2x minus 3.
Okay.
Is everybody? So now we're going to go through and we're going to look for our sign changes. Notice I went from x to the 5th x cubed, right? Doesn't matter, right? You don't have to have all the exponents. They just have to be in order, and we're going to look for sign changes. And so when you look for your sign changes, that's positive, that's not a sign change. But when I go to positive, negative,
That's 1.
there's a sign change.
Another one.
Negative to positive, that's a sign change. Positive, negative, that's a sign change.
Another one.
And so how many sign changes do we have?
3.
We have 3 sign changes, which means we're going to have we could have 3 positive zeros. Well, how many total zeros are we going to have? 5. So how many negative?
2.
2. And the first row always has 0 imaginary.
Stealing.
Okay, and so now imaginaries are going to steal, and they're going to steal in pairs. So the first thing we're going to do is we're going to try to steal from the positives. So we can steal a pair from the positives. How much is left here?
1.
1. Remember, each row needs to add up to, in this case, 5, whatever the degree is. All right, now I'm going to put all the positives back. Now the imaginaries are going to steal from the negatives. So what's it going to take here?
0.
We okay with that?
Yes.
And the very last stage is they're going to get greedy. They're going to steal from positives and negatives. So how many imaginary answers are we going to have? 4.
4.
And then what's left here? 1.
And then 0.
And then 0.
1, 0, 4.
So do you see how the imaginaries have stolen all they can?
Yes.
Why are they?
They're greedy. All right. This kind of makes sense.
Yes.
Okay. Last example of this part. So let's have 4x to the 6 minus 5x to the 5th minus 4x
Minus 4.
to the 4 plus, let's do 5x cubed. So I got 1,
I think it's just a number.
plus 4x squared minus 3x minus 1.
Okay. Should we make a chart?
Huh? Yep.
Okay. Chart. It's minus that.
And so now we want to check our sign changes. And so when I look for my sign changes, I get 1 sign change, 2 sign changes,
3 sign change.
3 sign changes.
All sign changes.
Oh, I think that's all I have, right? I only have to, oh wait, I want to change this.
4 sign
I wanted 4. So we're going to change this one little bit. We're going to change
That
the last.
changes my choice.
Maybe you should have gone ahead.
Okay.
I was just trying to challenge.
Yes. All right, so we have 4 sign changes.
Okay.
So if we have 4 sign changes, that means we're going to have 4 positives, right?
Yeah.
How many negatives?
2.
2. Right? And at this point, we want to see how much, we want to see, the imaginaries want to see how much they can steal from the positives.
Okay.
So the first thing they're going to do is they're going to steal 1 pair from the positives. If they steal 1 pair from the positives, what's left?
2. There's 2, 2, 2.
Everybody okay? We get 2, 2, 2?
Yes.
And this is me, this is imaginary stealing 1 pair. All right, the next time, can I steal 2 pairs from the positives?
Yes.
So if I steal 2 pairs from the positive, what's left?
0, 2, 4.
0, 2, 4, right?
Now that's only
So if we've stolen everything we can from the positives,
Now
right?
it's negative.
So now the positives go back full, right?
Yeah, you have to be fair.
Yeah. Now imaginaries are going to steal from the negatives.
Okay.
Can imaginary steal from the negatives?
Yes.
They can steal 1 pair from the negatives, which leaves nothing, right?
Yeah. And you can steal from both.
Okay. So we've stolen all we can from the positive, we've stolen all we can from the negative. Can we steal everything?
Yes. Those greedy people.
So if we steal everything, we get that.
Can't you? Oh, wait, never mind.
Yes.
Wait, could you steal only one, like, set from each and end up with 2, 0, and 4? Or is it just like all of them for the last one?
Well, you gotta have, if you do 2, 0, 4, remember they all have to add up to 6.
That adds up to 6.
That adds up to 6. 204.
2, 0, oh, what? Oh wait, did I mess up on that?
I mean,
No,
no,
you
no,
just-
she's
that was
just
correct,
asking
that
if
was
she
correct,
can
that
take
was
1 pair
correct,
from
that was
negative
correct,
and
that
1
was
pair from
correct, that was
positive.
Oh, yes. Oh, whoa, well, yeah, we have, okay, 1 pair of each, yeah.
Yeah, it's 2, 0,
So
4.
2, 0, 4, thank you.
I had that written down.
I have a
Thank you, I
question.
missed that, yeah. Yes,
Okay, so
So
do you? Why does it always steal in like 2s or pairs?
that's why they steal in pairs.
Yeah.
When you find answers, complex answers always come in pairs,
Okay.
right? Because that plus or minus, they always come in pairs.
No, I mean like
But why can't you steal 1 from the positive and 1 from the negative?
That's
Like,
what you just said.
okay,
No, I mean 1, like the number 1. Like it keeps taking like you take 2 from.
well, because complex numbers always come in pairs.
Okay, so you have to steal by 2.
You have to
Wait,
steal
but I wanna, why can't you take 1 from positive and 2?
1 from the negative.
Because
I've
they come in
actually,
pairs.
the last example today, I could explain when I need a picture, and the pictures are coming.
Okay.
And so the last one is gonna be 0, 0,
Just
6.
a pair from zeros and a pair from positives, but I
The
don't
last
think you-
0, 0, 6.
Like,
Yeah.
Wait, how
one,
is
two.
that? Oh no, because you can steal 2 from
Yeah.
that.
The 1
2 from
positive, the 1
4
negative
from
to make
that.
a pair, that's what it's supposed to be.
So
All right.
We're right.
So, as far as Descartes' rule of signs works,
Good job.
you're given a polynomial and you make the chart,
Chart is good.
right? That's how the Descartes' rule of signs work. Does it help you solve anything?
No.
Not one bit, right?
liked
Is it hard?
No.
No, I think this is easier than what I have been doing.
So then what is the point if it doesn't help you in any way? It just gives you like a more comprehensive.
Help is a picture.
Wait, so well, they
Yeah, it's picture.
wait, so wait, well, they heard.
Not the graph. No.
No, but I'll talk about that in a
Was that the
okay.
graph of that problem?
So, okay. So what we're gonna talk about today is how do we use a graph to help us, right? This is the graph of this polynomial.
Okay.
Okay. So this is the graph of this polynomial. For how many zeros does this have?
3.
Okay, so this has 3 zeros. All right. A 0 is the same thing as an x-intercept. It's where the y value is 0. So when I look at this graph, I am interested in where this thing crosses the x-axis. So if I look at this picture, what are the zeros of that graph?
Negative 3, 0, and 1.
Negative 3.
That is definitely
Oh, I'm sorry.
zero.
Negative 3, negative 3,
one
and negative half, and then 2. I'm sorry.
Okay.
I did the wrong points.
So I'm going to write down negative 3 and I'm going to write down 2. I'm going to write down negative 1/2, but we're going to talk. I want to see how confident you are.
I'm quite confident.
All right.
We're basing
If
it
you
off
had to
of-
bet $100, would you bet $100 it crossed at negative 3?
No.
Yes.
No.
I would.
Yes.
No.
Okay.
No. What's this bit?
How confident are you that this crossed at 2?
No.
Pretty confident.
No.
Pretty
I would
confident.
bet in the
No.
thousands.
No.
Okay, bet no. Okay.
I would keep my money.
How confident are you it crossed at negative 1
I
half?
would bet the five.
Yeah.
Maybe a
So
dollar.
what I'm hearing is you're significantly more confident about the negative 3 and the 2 than you are the
Oh my God,
negative
we
1
should
half.
try, we should try negative.
They're all wrong.
Okay, now, so, but the point is, with this graph, we're at least confident in some numbers, right? So based on this, it looks like 2 should work, right?
Yeah.
Oh,
So how do we know, how do we test to see if 2 works?
you plug it in for x.
You plug it in the synthetic division, right?
Woo!
So everybody do that. Like, write down your synthetic division.
Drew,
That's it.
do you know how to do math?
Oh, I'm
Oh.
4,
Just got roasted.
14,
It
there's
works.
3.
Oh.
Okay, it works. Now,
Oh, really?
all right, so the 2 works. So now that we know the 2 works, what's going to be a factor?
X minus 2, 4. 4.
X minus 2, and then what goes here?
Whatever that thing is.
Well, 2x squared plus 7x plus 3. Okay.
Yeah, I knew that.
Okay. So I get 2x squared plus 7x plus 3. That's a quadratic.
Yeah, it is.
Okay, fast.
Okay, hopefully we can factor this. So if we factor it,
2x.
2x and x, we have a plus 3 and a minus 1, or plus 1.
Yeah, 2 and
1x
plus
plus 6x gives us 7x.
Yeah.
All right, so we factored it, right? So we've successfully factored our polynomial, all right? So if we, what's
X plus
1
3.
half.
Oh.
this gives us
Negative
negative 1
1
half. What does this give us?
Negative 3.
Oh, good. Our
Yay!
all right, our guesses worked.
I
Okay.
get $1,105.
Okay. So does this kind of make sense?
Yeah.
All right.
Yeah.
Do you see how the graph helped?
Firebox.
Mhm.
All right. So let's try it again.
Firebox.
But we still have to check it anyways, right?
Don't tell me you have this
Wait,
fire.
like we still have to check it with synthetic division. So
I bought the
We
one
could do it
bottle
without
of
the
it,
graph.
Actually, no, she just gave it to me.
Okay.
I thought I lost it. She left it.
Okay.
Don't worry about
Hey,
it.
Cynthia. Jack from me.
I don't think I want to know. It's okay. Let me see.
All right. Everybody write that polynomial down.
okay, start thing the
Okay. So the degree of this is 4, right?
yes.
Is that right? Okay. Now, let's look at the picture and let's find out answers. So we've got to get 4 answers, and do we have 4 answers in our picture?
Yes.
Yes.
Yeah. The problem is, not all 4 of the answers are obvious, right? Like, based on this picture, what answers do you know work?
So
Negative 3.
there's negative 3 and we know 2.
So we know that negative 3 and positive 2 work, right?
Yeah.
Yes.
All right, so based on that information, do negative 3 and positive 2 and see where we are. Like, treat this problem just like we did the last one.
It works.
Okay, so I'm curious. How many of you started with negative 3 first?
I did.
How many of you started with 2 first? Okay. Now, since most people did with 2, I'm actually going to start with negative 3. Does it matter?
No.
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 You're going to end up with the same spot, right? So, since most people started with 2, I'm going to start with negative 3 just to show that you can compare. But if I start at negative 3, right? So I bring down the 1. This time this is negative 3. I get negative 6, 18, 9, negative 27. I get a negative 2, 6. I get a 0, right? And then next,
And then 2.
I'm going to use 2. And so 2 comes with 2, negative 4,
8.
and I get 0. So even if you did 2, then negative 3, you still got the 1, the negative 4, and the 1.
Yes.
Now based on that information, here's what I know. I know that I've got x plus 3,
Oh, it's a quadratic. That's
and I end up with x minus 2.
Wait, I'm confused.
These are
Okay.
quadratic.
Shh, wait. Okay, are you okay?
Up to here, yes.
Yeah, okay. And so now what we've got left here is x squared minus 4x plus 1. Is everybody okay how we got to here?
Yes.
Why did you draw your parentheses so far out?
Well, I didn't know how much room I needed. Okay, now, so now what we would like is factor this, right?
Yeah.
There's a problem.
It doesn't factor.
It doesn't factor.
Yeah.
Oh.
But that's okay because when you have a quadratic that doesn't factor and you're trying to find zeros, what do you use?
Quadratic formula.
You use the quadratic formula.
Maybe not that.
Okay. So now I'm going to use the quadratic formula. So when I do this, okay, negative b, so 4 plus or minus the square root of this thing squared, minus 4 times 1 times 1, all over 2 times 1. So I get 4 plus or minus, this ends up being square root of 12, which is 2 square roots of 3, all over 2. As far as the simplification of this goes,
2 plus or minus square root
Yeah,
of 3.
4 plus
I end up with 2 plus or minus the square root of 3.
2 plus or minus. Yeah, square root of 3.
Yeah, plus or minus, right?
Yeah.
So I'll get a 2 plus the square root of 3, and I'll get a 2 minus the square root of 3. Now, I want to try to connect this to the picture. And remember, these are the two dots that we didn't know quite where they were?
Yep.
I'm betting this is
2 plus.
2 plus the square root of 3, and this one's 2 minus the square root of 3.
Yay.
So again, on Alex, right, if you're asked to find an answer, there are lots of calculators that tell you what the decimal equivalent of this. But that's not what Alex wants. Alex is going to want the 2 plus the square root of 3 and the 2 minus the square root of 3 for the exact
Wait,
answer.
what would it put like x plus or x minus?
No.
But
No, they want, because this would be if I wanted factors, but typically I'm asking what are the zeros. All right, and now I've got my last example.
The same one as the first. This one.
So here's the last example today. And the last example is 7x cubed plus 39x squared plus 73x minus 39. So before we look at the picture, how many zeros should we have?
3. 3.
Is everybody okay? We're going to get 3. We should get 3 answers.
Yeah.
And so let's look at the graph.
Oh.
Okay, Queen.
All right. And so here's our picture.
Period.
That's not good.
Now I have all right. Well, how many zeros do you see in this picture?
1.
Okay. So technically I see 3, and I want to tell you why I see
Does
3.
it bounce?
Okay, it didn't bounce.
Okay.
We have one real answer. Anytime it crosses the x-axis, that creates a real answer.
2 imagine.
Do you see this little hump here?
Yes.
It's like if it had gone a little higher, we would have gotten our other 2.
Yeah.
Anytime you get a little hump that doesn't quite cross, it's going to create 2 imaginary answers. All right?
Yes.
But, and also, if we look at it, you know, if I look at this, if I'm looking at this, you know, this x-intercept,
It's actually.
it's a little bit bigger than 5. It's like, I'm not quite sure what it is, right?
5.1.
Well, but how do we find out the answer? So this is a case where even if I give you a graph, it doesn't help us figure out all the zeros.
So you have to guess.
Does that make sense?
Yes.
Okay. So what I'm actually going to do is give you one. I've got to give you a hint.
Okay.
All right. And here's the hint. The hint is, so we know there's 3 zeros, and our job is to find the 3 zeros. I'm going to tell you that -3 plus 2i is a 0.
Oh, okay.
Right? So even with the graph, we're not doing so hot, right?
Yeah.
But I'm going to tell you that -3 plus 2i is a 0.
Still
Well, if -3 plus 2i is a 0, what else is a 0?
Opposite conjugate thing.
Okay, -3 minus 2i is a 0. All right, that's fine. Oh, well, this looks like the problem I did at the beginning of class, doesn't it?
Yes, sir.
Oh, and I have it still written down.
So if this is a 0 and this is a 0, that means we get, what, x plus 3 plus 2i is a factor, and x plus 3 minus 2i is a factor. Is everybody okay with that part?
Yeah.
Yes.
Yeah.
And we multiplied that whole thing out.
Yeah.
If we multiplied that whole thing out, we end up with x
X
squared plus
plus
6x plus 13.
Let's go.
Okay, now, so we're actually not doing too bad because, all right, we need 3 zeros, and we've got 2 of them. How do we find the third one?
Factor that.
Well, the problem is I can't, well, synthetic doesn't work with that.
Yeah, we have a
Quadratic
polynomial.
Okay, just wait a minute. I do like, okay, so we need to somehow factor this. And here's what we know. we know that this whole thing is going to factor as this thing times something else. Because if that's a 0, that's also a 0, which means these are factors. So this whole thing is going to be this thing times something.
Great.
Okay.
So we're going to go back in time a little bit.
divide
I don't know if you remember this example, but let's say I wanted to factor the number 91. Now you may not know exactly what goes into 91, but if I tell you that 7 goes into 91, how do I find out what goes here?
Divide.
I do 91 divided by 7.
Yeah.
So if I want to figure out what this is, guess what I'm going to do?
I'm going to
I'm going to take this divided by this.
Yeah.
You do the long
So I have to do long division. So I'm going to have x squared plus 6x plus 13, and I'm going to divide that into 7x cubed plus 39x squared plus 73x minus 39.
Oh, it's so much more.
Now, while that seems painful, it's not going to be too bad, or at least I hope. What goes here so that this times this gives me 7x cubed?
7x.
7x.
A 7x. All right, so this times this is going to give me 7x cubed. This times this gives me a plus 42x squared. And this times this gives me a plus 91x. Now I subtract. Minus, minus, minus. This cancels because I want to. 39x squared minus 42 is a negative 3x squared. 91 minus is 18. Negative 18x minus 39. And what goes here so that this times this exactly equals a negative 3x?
Negative 3.
Negative 3, so I end up with negative 3x squared minus 18x
Oh, yay.
minus 39. Oh, look! We get a 0.
Oh, no.
Yay!
This man's a math magician.
So we know this is 7x minus 3. And if we know this is 7x minus 3, what do we get?
Then you get x.
0.
7x minus 3.
3 sevenths.
3, 7,
I don't know.
Oh, yeah, it is 3
I just
sevenths.
guessed.
3 sevenths is.
Wait. My picture's bad. Apparently that's not the graph of the
Hey, yo, bad picture, Chad.
I know, wait. Okay, wait, I'm gonna go ahead and pause this.
Okay.
Actually, stop it.